All right, Team Impact. Hope you're enjoying your morning, afternoon, whenever it is. Enjoying the weather outside. Hope you have a nice hill you can go sled riding today. Bundle up and take care of having some fun today. We got to take care of a little business today, math. Real quick, if you didn't finish your digital activity from yesterday, I'm going to give you until tomorrow to do it. And it will go into third 9 weeks. I have your quiz to return to you tomorrow. And then also, we're going to move on to combining like terms, lesson 5. This will be due tomorrow. So really, this is the only new thing that we have. So let's please make sure we get this done so that we can have a good start to the third 9 weeks. Okay. All right. Well, here we go. Mrs. Vara's science class collected the following items. Grouped alike terms, all right, together to determine the total number of each item collected. All right, so let's look for our leaves here, okay? So when we look for our leaves, I like to cross them off when I count 3, 4, 5, 6, 7, 8, 9, 10. 10 leaves. All right, and then I'm going to put an X over these so I can differentiate. 2, 3, 4, 5, 6, 7. All right, so we just combine some like terms. Algebraic terms can be regrouped or can be grouped in a similar way by combining like terms. Okay, like terms. Algebraic terms are considered like if they have the same variable, the same letter, right? With the same exponents, right? So you'll see what we mean in just a few minutes here, okay? Constants, number constants, or numbers, remember they were just numbers, right? Are like terms since they do not have a variable. So we can combine constants, okay? Okay, so let's go ahead and take a look at this first piece. For each set of terms listed in the table below, circle the two like terms and cross out the unlike terms, then explain your thinking. Okay, so this and this is like, and that is unlike. Why? Because they both have the variable y. Right? So now we have a 10x, a 5x, and a 2x square. Right? These don't have exponents, so they are like. Right? These also have, all right, and we're going to shorten it, have just an x. Now, if we go down the bottom one, all right, we have a 10 and a 7. So we have two constants and we have a coefficient and a letter x. So our constants, all right, are both 10 and 7. Constants 10 and 7. So remember, a constant's just a number. The number before a variable is called the coefficient, and the letter is called the variable, as I just said. Okay. All righty. So what we're going to do next, okay, is we're going to start to combine like terms. Okay. They want us to use these tiles, but I think they're a little bit confusing right now. You'll get into those later when it's a little bit more involved. But what we're going to do is just combine our like terms, right? So I'm going to combine the 2x and the 3x. So I'm going to combine the coefficients. So 2 plus 3 is 5. And I'm going to bring the x along for the ride. And then I'm going to add 3. See, what I do sometimes when I have a lot of different numbers or constants and variables and coefficients is I start labeling them a little bit different. I underline these two like terms and that was by itself. So here, if you look, I may circle the 4s, right, and underline the x's. Okay, so let's start with our x's. So 2x plus x is 3x. Remember, there's really a coefficient of 1 in front of that x, okay? And then we're going to add 4 plus 1 is 5, okay? So 3x plus 5, that simplifies down to that. Next one, again, x and x, two constants, but this one's a little bit different. It has a minus in front of it. So let's take a look at this. X plus x is 2x. Okay? Now, 3 minus 1 is 2. Now, some would ask, what happens if it was 1 minus 3? Then it would be negative 2. But we're not going to get into those negatives yet, but that can occur. Okay? So we're just combining like terms so far. Let's flip it over and see what we have here, okay? All right, so on the next page, well, we have some more vocabulary. We can simplify algebraic expressions by combining like terms, right? More of the same. You're going to identify, all right, the like terms, all right, and be careful to keep the sign that is in front of the term and combine the like terms to simplify. Okay, basically what we did. Okay, and you're going to notice that they're showing what I showed. They're boxing, they're going to circle. I underlined like I did back here. Okay, so let's get started here with this. All right, so 11x and 9x is 20x plus 19. That is simplified. We don't know what the variable x stands for. Okay, there's an x's, there's a y. 3y plus 14 minus 5 is 9x. Now, some would ask, can I write 9x plus 3y? Yes, you can write it either way because it's the commutative property, right? I have some c's, and I have a couple constants. 16c plus 5c is 21c plus 9 minus 3 is 6. Okay? What I'd like for you to do is pause the video and do 3 at a time, 5, 6, 7, and then check it. Check it with me, okay? So that way you can get a good review and a good practice on this, okay? All right, so if you're clicking back on, here we go. I'm going to underline this, circle this. There's nothing to combine to the y, so it is 11y. 9 plus 5 is 14. Over here, I'm going to combine my a's and circle my c. 11a plus 3a is 14a. Now, there's a minus, a subtraction in front of that. So now the sign in front carries it, minus 5c. So we have to be very diligent about that, right? Next up, 4d minus 3d. Ooh, 4 minus 3 is 1d, or just d. It's given, it's inferred that there's a 1 in front of that, so we don't need to write it. Is it wrong if I write the 1d? Well, no, but still, we want to write it the best way. So it's d minus 8. Minus 8. Okay, next up, we have 8x squared plus 10x plus x. So remember, this is different than those two, okay? We cannot combine this because they don't have a square with it. So I'm going to start with that and get rid of that. 10x plus x is 11x, right? Okay. All right, let me get a drink of water here. We're going to roll on. All right, number 9. 16w plus w. So let's underline those, circle those, and I'm going to get 21w plus 14. So I've combined my coefficients, and now I have my constants. If you just heard Mrs. Rehack pop in there, she's saying good morning. All right, next up. So now I have a bunch here. I have an R and an 11R. And now I have a 7Q and a 13Q, right? Okay, so 18R minus 11R. All right, it's just going to be 7R. And then I'm going to combine these two. 7 plus 13 is 20Q. Okay. So remember, the sign carries in front of the number, the coefficient, it carries with that. Okay, let's take a look at the next one. I have some t's here. 6t plus 2t is 8t. And I have a couple s's, right? 19s minus is minus 9s. D, 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 they're all D's. Okay, so let's just work this left to right. 15D plus 3D is 18D minus 7D minus D. 18D minus 7 is 11D minus D. 11D minus D is 10D. So I just kind of worked that as an order of operations, left to right deal there. Okay. Number 13. 4x squared plus 14x squared minus x. So I can combine these two, and this is kind of the Lone Ranger there, right? So I'm going to combine those and get 18x squared minus x. Minus x, okay? So I hope you did pause the video and you're checking it right now. However you did it. If you need to check it out, pause it some more. And it's right there, okay? But it's important. It's important that you're circling and underlining or boxing, whatever works for you. Write an expression to represent the perimeter of the rectangle. Perimeter is the distance around. So if that's 2w, this is 7w plus, that's the same thing over here. So I'm going to write an expression, so I'm going to combine my like terms, right? But before I do that, I'm going to go ahead and write this over here because, and that's 1.5, that's what that equals, right? There's a couple different ways to do this, but what I'm going to do is combine all of my w's because I'm going to get the perimeter. I'm going to build a fence. 2 plus 7 is 9. 9 plus 2 is 11. 11 plus 7 is 18w plus. Okay. Then I'm going to combine this to this. This constant and this equals 3. Okay. So I wrote down some additional information. I could have doubled this. I could have multiplied it by 2. But I thought it was easier just to do that. And good morning. Number 15. Miss Tig wrote an expression on the board as shown, but parts of the expression got erased. She knows the expression simplified equals 10x plus 13y. Find the missing values. Okay. So I need to get to 10x, and this is a minus 2x. So what number minus 2x would be 10? Well, I'm just going to add it back, and I'm going to end up with 12x because 12 minus 2 is 10, right? And then I need to get to 13y. Well, I have 8y's. So what number plus 8 is 13? Well, it's certainly 5. So 5y plus this equals this, and 12x minus 2 equals that. And that's what we're looking for, okay? Okay, so I hope all that made sense. We're going to hit this again tomorrow with algebra, with properties. So Thursday's going to be a big review day for us. But your homework, not much, but take your time with it. Do a good job. Underline and circle. And again, make sure that digital activity is done. And we'll have a massive review tomorrow. So I hope you enjoy the day, guys. We'll see you.